Okay, welcome back to Mtali TV. My name is Robert Mtali and I'll be your pure physics tutor. Alright, so in today's lesson, we're going to learn the topic magnetism. We're going to learn the topic magnetism. Alright, so we need to define what magnetism is first. So magnetism is simply a force that forces two objects to be attracted to each other or to be pushed away from each other. So that is the definition of what magnetism. Once we know the definition of magnetism, we need to know their properties. So properties of magnetism. Number one, we have that the end of the magnet is called what? The pole. The end of the magnet is called what? The pole. Okay, then number two, if a light magnet hangs on a string, one end points towards the north. This is called what? The north pole. Then number three, the other end point towards the south. This is called what? The south pole. It's called what? Like poles what? A pair. Meaning that when you get the north pole, you get two magnets. You get the north pole, the first magnet, and the north pole of the second magnet, and you try to make the two connect. You'll find that those two magnets will repel because they are trying to make them contact on the same poles, and there's a law which is called what? Like poles repel. So when you get the north pole of the other magnet and the north pole of the other magnet and you're trying to connect the two, they repel each other. That is what we call the what? The like poles repel. So the opposite is also true, meaning that when you get the north pole and the south pole and you try to connect the two, those two will be attracted to each other. Okay, so magnets attract some materials, e.g. like iron, cobalt, nickel, and steel. These materials that can be attracted to a magnet are called what? Magnetic materials. Other materials, e.g. like copper, plastic, paper, wood, that cannot be attracted to a magnet are called what? Non-magnetic what? Materials. Alright, so now let's move into another concept under magnetism that we call induced magnetism. So this thing, we need to define what induced magnetism is. So induced magnetism is simply the temporary magnetization of a magnetic material when it is placed near to or in contact with what? A magnet. For example, if a nail is placed in contact with a permanent magnet, the nail is magnetized and it also attracts other nail. The end of the nail near to the north pole of the permanent magnet becomes induced south pole, and the other end becomes the induced north pole. Then the other thing we should look at is what we call the magnetic materials, specifically iron and steel. So iron and steel are common magnetic materials, but they have different properties as shown below. For example, here, if you look at iron, for instance. So iron, in terms of magnetization, it is easy and strong. In terms of demagnetizing, it's very easy. In terms of application, it is used in the electromagnetic. For example, it is used in the transformers and in the electric bell. So in terms of naming, iron is a soft magnetic material. Okay, now let's look at steel. So steel, in terms of magnetism, it is hard and weak. So in terms of demagnetizing, steel is very hard. Then in terms of application, steel is used in permanent magnets. Steel is in what? Permanent magnet. For example, in the DC motor generators. Then in terms of naming, it is a hard magnetic material. So if iron and steel are placed in a contact with a permanent magnet, they are induced. Then they attract some small nails. Iron attracts more nails than steel. Then if they are removed from the permanent magnet, iron releases the nails soon, but steel attracts some nails. So for example, here if you look at the diagram there, you can clearly see that iron attracts more nails and also iron drops those nails immediately becomes disconnected from the permanent magnet, while still, because the hard magnetic material, it still remains somewhat nails. All right, so that is all about induced magnetism. Now let's look at magnetism. So how to make a permanent magnet, how to magnetize a hard magnetic material. So how do we make it magnetism? So first, we have the first method, which is called what? Stroking method. Stroking what? Method. If the permanent magnets are stocked along a hard magnetic material, the hard magnetic material is magnetized and it is changed into a permanent magnet. So there, if you look at the diagram, you need to move the permanent magnet in the anti-clockwise direction, so that by the time you are finishing making a 360 degrees turn, that hard magnetic material to become what? A permanent magnet as well. So you need to pay particular attention that where that one there, where the north pole is placed, starting from, is what it becomes the north. And since that where it's starting from becomes the north, which means the other end of that hard magnetic material becomes what? The south. Alright, so the other method is what we call the electrical method. What we call what? The electrical what? Method. If the hard magnetic material is placed into a solenoid direct current, the hard magnetic material is magnetized and is changed into a what? A permanent magnet. Alright, so if you look at the diagram there, you clearly see what happens. So first thing first, you need to put what? The hard magnetic material into what? The solenoid. So the solenoid there, once the switch is closed, current will begin to pass through that solenoid, and as current passes through that solenoid, since current is moving in one direction, it will cause the dipoles. Dipoles are simply smallest particle in the magnetism. So it will cause the dipoles to be arranged in one direction. Once the dipoles are arranged in one direction, that's how a magnetic material becomes what? A magnet. So that's what happens. So another thing we need to look at is how to find the pole on the electrical magnet. How do you find the pole on the electrical magnet? So use the law, what is called the right hand grip rule. The right hand grip rule. So there on the diagram, you can see that you have the right hand there. So what do? You tend to grab the solenoid. You can just imagine this. So these fingers that holds the solenoid, the thumb points to the north pole, and so once you identify the north pole, automatically you identify the south pole. So it's very important that you know the right hand grip rule. So just grip using your right hand, then these fingers should go in the direction of the current, in the direction of the current. Where the current is going is where your fingers should go. And once you follow the direction of current properly, and where the thumb points at is what? North pole. So this is the best method to make a powerful magnets. And the magnet which is made with a solenoid is called what? Electromagnet. Okay, so the other thing we should look at is what we call demagnetize. How to demagnetize? So I've learned how to magnetize. Now we need to learn how to demagnetize. Alright, so how to demagnetize a hard magnetic material? The first method is what we call heating. Heating. If a magnetized material is heated to a higher temperature, it will lose its magnetism very quickly. Why? Because the dipoles inside the magnet will gain a lot of kinetic energy, and they'll start moving around. Hence, this table, they will move in all direction. Once the dipoles move in all direction, it means that hard magnetic material will not be magnet anymore, because the dipoles are not moving in one direction, or they are not arranged in one direction. Then the other method is what you call hammering. So if a magnetic material is hammered many times, the magnetism becomes weaker and weaker. Eventually becomes demagnetized. Right. So then thirdly is the use an alternating current and the solenoid. Alright, so remember when we're magnetizing using the solenoid, we're using what? Direct current. So remember when we're making a magnet in the solenoid, on methods of making a magnetism, we used a DC current. This is very important. Please pay particular attention. We use a DC current when making a magnet using what? The solenoid. But when we want to demagnetize the opposite, we use what we call what? The AC, which is not known as what? The alternating what? Current. Why? Because the alternating current changes direction periodically. Since current changes direction periodically, it moves in the east direction to change again, move in the west direction, just like that. Changes direction what? Periodically. Because of that, the dipoles inside the hard magnetic materials will also what? Be changing direction. Hence, they will not be arranged in what? In one format. So hence, demagnetizing the what? The magnetic materials. Alright, so then once knowing the methods, the other thing we need to know is what? Electromagnet. Electromagnet, magnet. So ion, when you want to make an electromagnet, what is commonly used is what? Ion as a core electromagnet, because it is easy to magnetize. It's also easy what? To magnetize. So the strength of magnetism depends on the current, number of turns per unit length of the solenoid, and the material of what? Of the core. So if you want to make a magnet, an electromagnet, its strength will depend on what? The current you use, the number of turns per unit length of the solenoid, and the material of core. Alright, so that is it about the electromagnet. Alright, so once we're done with that, we need to look at the magnetic field. We need to learn about the magnetic field. Alright, so we need to define what the magnetic field is. So the magnetic field is defined as the region around a magnet where magnetic effect can be what? Detected. So once you define the magnetic field, we need to know how to draw the magnetic field lines. So firstly, we need to place a bar on a plain paper. Then secondly, we need to place the compass near one end of the magnet. Then thirdly, we need to plot two dots at the ends of the needle. Then fourthly, we need to move the compass to the position where the previous dot 2 is with another pole. Then you need to plot one dot at the other end of the needle. Then you need to repeat the same process 4 and 5 until the compass reaches to the other pole of the magnet. And 7, you need to connect dots from one end of the magnet to the other. So this is how it looks like when you are done. Right, so then lastly, we need to look at what is called the electromagnetic effect. The electromagnetic effect. So under this effect, we need to learn what is known as the Fleming's left-hand rule. Fleming's left-hand rule. If a current flows in a wire in the magnetic field, a force acts on the wire. So the direction of the force can be found by Fleming's left-hand rule. So how does it work? So there, you get your right hand, the thimble will become this force, and the first finger you will represent, it will show the direction of the magnetic field, and the second finger will show the current. So there on the magnetic field there, you need to point the first finger in the direction field, and where the fingers point is the force, and where the second finger points is what you call it, the current. Alright, thank you for watching the TV. I hope you have learned one or two things. If you have, please subscribe, like, and leave a comment.